At 7 a.m. on March 10, 2019, at Addis Ababa Boyle International Airport, the capital of Ethiopia, a Boeing 737 MAX 8 was preparing for departure to Jomo Kenyatta International Airport in Nairobi, Kenya. The flight number was Ethiopian Airlines Flight 302, with an expected duration of approximately 2 hours and 12 minutes. The aircraft assigned to this flight was a nearly brand new Boeing 737 MAX 8, which had been in service for only 4 months and had accumulated 1,330 total flight hours. The Boeing 737 MAX 8 is part of Boeing's latest generation of the 737 series. Flight 302 was commanded by Captain Yared Getachew, a 29-year-old pilot and one of Ethiopian Airlines' youngest captains, with over 8,100 total flight hours, including more than 4,000 hours on the Boeing 737 NG and 103 hours on the 737 MAX. His co-pilot was 25-year-old First Officer Ahmed Noor Mohammed, who had 360 total flight hours, 207 of which were on the 737 MAX, all logged within the 90 days prior to the flight. However, his training record showed strong performance with no negative evaluations noted.
In addition to the 2 pilots, there were 5 cabin crew members and 1 dedicated flight safety officer on board. Along with 149 passengers from 35 different countries, the flight carried a total of 157 people.
After all passengers had boarded, the captain began reviewing the technical logbook and configuring the cockpit flight control systems. Meanwhile, the first officer conducted the external walk-around inspection of the aircraft. Prior to takeoff, the pilots set the elevator trim to an angle of 5.6 degrees, a crucial parameter to help the aircraft rotate smoothly during liftoff. Keep this setting in mind. It would later become a key factor in the accident.
The initial phase of the flight was to be flown manually by the captain, with the first officer assisting and monitoring the flight throughout. At 8:25 a.m. local time, after all ground preparations were completed, Ethiopian Airlines Flight 302 was cleared for takeoff from runway 07R.
At 8:36 a.m., the flight crew entered the runway and waited for takeoff clearance. Up to this point, all systems in the cockpit were functioning normally, with no warning indications present. At 8:37 a.m., the control tower cleared Flight 302 for takeoff via the standard Solo 2L departure route. The captain first advanced the throttles to 40% thrust, confirmed engine stability, then engaged the auto throttle, allowing the engines to reach maximum takeoff power. The Boeing 737 MAX began accelerating down the runway, with everything proceeding according to standard procedures. But at that very moment, unnoticed by the flight crew, a potential hazard on the left side of the aircraft had already quietly activated. And it was at this moment that the disaster officially began. Only 40 seconds after takeoff, just as the main landing gear left the ground, a critical malfunction occurred. The angle of attack, or AOA sensor, on the left side of the aircraft's nose suddenly failed. As the landing gear retracted, the master caution light in the cockpit illuminated immediately, the first sign of abnormality. On the first officer's instruments, a warning related to the anti-ice system appeared, while on the overhead annunciator panel, an alert for the left AOA sensor began flashing. Just as the first officer urgently called it out, the systems quickly descended into confusion. Initially, the data from the faulty sensor showed only a slight deviation, but within seconds, the values spiked sharply to a dangerous level. This kind of reading was highly abnormal for an aircraft that had just taken off. Meanwhile, the right side AOA sensor, on the first officer's side, still showed a normal value of 15.3 degrees, well within the safe range. However, the aircraft's central flight control computer was programmed to read data only from the captain's left side sensor. At that moment, that sensor was already providing highly inaccurate information. As a result, the system mistakenly determined that the aircraft's nose was pitched too high and believed it was at risk of stalling. Because of this erroneous sensor input, multiple emergency alerts suddenly appeared in the cockpit. The overspeed warning tape on the captain's display lit up without warning.
The system determined that the aircraft was about to exceed its operational limits. The control column began to shake violently, emitting a loud noise. This was the system's warning of an imminent stall. At that moment, both pilots were shocked and became extremely tense. Because the system was receiving data only from the faulty sensor, the captain's display began showing incorrect altitude and airspeed information, values that were much lower than the actual readings and dramatically different from what appeared on the first officer's display. To respond to the situation, the captain immediately reduced the aircraft's pitch from 15 degrees to 8 degrees and re-engaged the trim system. This system helps the aircraft maintain a stable flight attitude without requiring the pilot to keep constant pressure on the control column. But the confusion didn't end there. The aircraft's flight director, used to indicate flight attitude, also began to malfunction, flashing intermittently on the display, further disrupting the judgment of the two young pilots.
According to Ethiopian Airlines standard operating procedures, autopilot mode may only be engaged after the aircraft has climbed to at least 400 feet. It also clearly states that autopilot should not be activated if there are signs of a stall. Despite this, the captain repeatedly attempted to engage the autopilot. However, the system rejected the input twice, issuing warning alerts each time. It appeared that the captain was still applying significant manual input, resulting in an unstable flight attitude that prevented the system from taking over. This left the captain increasingly confused and frustrated, prompting him to exclaim in frustration, "What is going on?"
Ethiopian Airlines Flight 302 continued to climb and had reached an altitude of 400 feet. The flight director began returning to normal, and the horizontal and vertical navigation indicators on the control panel illuminated, signaling that the flight guidance system was ready. Nevertheless, the captain still had to manually control the aircraft to maintain stability, continuously adjusting the aircraft's attitude using the electric trim buttons. The captain instructed the first officer to contact the tower immediately. The first officer reported to ground control that they were flying on the Sola 2L departure route at a current altitude of 8,400 feet.
At this point, a clarification is necessary. Although the instruments indicated an altitude of 8,400 feet, the aircraft was in fact only about 750 feet above ground level. This is because Addis Ababa's Bole International Airport is located at an elevation of 7,656 feet above sea level. On Flight 302, up to this moment, the flight crew still had not reported any abnormalities to air traffic control. The first officer's display continued to show 8,400 feet, while the captain's side displayed an altitude that was about 400 feet lower. The two instruments remained inconsistent. After the aircraft climbed to 1,000 feet, the captain was finally able to engage the autopilot system. From that moment, autopilot took over flight control. However, this brief period of stability lasted only a few moments. At 8:39 a.m., the radar controller confirmed the position of Flight 302 and instructed the aircraft to climb to 34,000 feet and to turn toward the inbound waypoint when conditions permitted.
At this moment, the situation inside Flight 302's cockpit was becoming increasingly complex and dangerous. Although the flight data recorder did not indicate any clear altitude or airspeed errors, and no fault reports had been sent by the flight crew, in reality, multiple signs of unreliable airspeed were already clearly present. The left side control column continued to vibrate constantly. The airspeed indicator would suddenly jump, and the aircraft's speed readings fluctuated rapidly. These symptoms are typical indicators of pitot-static or airspeed sensor failure, a problem that has caused several major accidents in the past.
Even under intense pressure, the captain remained composed and attempted to regain control. He pressed the altitude change mode button, a control mode that allows the aircraft to automatically adjust altitude while maintaining the current airspeed. On the autopilot control panel, the captain set a target speed of 238 knots to help stabilize the flight. When he noticed the aircraft was flying too fast, which could have a negative impact on the wings, he immediately ordered the flaps to be retracted. He then began adjusting the heading to 197 degrees, following the earlier instructions from air traffic control.
However, shortly afterward, the captain changed his mind and instructed the first officer to report that they were unable to turn and would continue flying on the current heading. At that moment, the first officer did not respond immediately. About 4 seconds later, due to the aircraft's unstable flight condition, the autopilot system suddenly disconnected. At this point, the aircraft had climbed to 9,000 feet, which was approximately 1,450 feet above ground level. However, instead of continuing to climb, the aircraft began a slight descent. The flaps had been fully retracted, while the engines were still operating at maximum takeoff thrust, causing the aircraft to accelerate rapidly. Meanwhile, the left side control column continued to shake violently. Just before the autopilot disengaged, the Maneuvering Characteristics Augmentation System, MCAS, activated for the first time, automatically trimmed the horizontal stabilizer nose down to a value of 6 units, causing the aircraft to pitch downward rapidly for approximately 9 seconds.
Facing a loss of control, the captain still tried to remain calm and gave the order to report to air traffic control. "We are maintaining current heading. The aircraft is experiencing a serious flight control system issue."
However, before the captain could finish speaking, the Terrain Awareness and Warning System, or TAWS, suddenly began sounding an alarm in the cockpit. At that moment, the first officer finally began to carry out the captain's orders, contacting air traffic control to report that they could not continue flying the originally assigned standard departure route. Conditions in the cockpit were rapidly deteriorating. Red emergency alerts simultaneously appeared on both pilots' displays, and the terrain warning system continued to sound repeated voice alerts. The Maneuvering Characteristics Augmentation System, or MCAS, intervened for a second time, again forcing the horizontal stabilizer trim downward to 2.1 units, causing the aircraft's nose to pitch down even more steeply. The captain tried to pull back on the control column to raise the nose, but the required force had reached 41 kilograms, over 90 pounds, equivalent to a grown adult needing to exert full body strength just to control the aircraft. He pressed the electric trim button in an attempt to readjust the stabilizer and relieve the pressure, but only held it for 2 seconds, which raised the trim to just 2.3 units. Not enough to change the aircraft's downward trajectory.
Even worse, this action triggered the MCAS to prepare for a third intervention. The pull force on the control column increased by the second, likely marking the first time in the captain's flying career that he encountered such intense physical resistance. Just as the crew received air traffic control's instruction to continue flying in the direction of the runway, MCAS activated for a third time. At the same time, the TAWS, or Terrain Awareness and Warning System, continued to issue urgent audible alerts. The pressure inside the cockpit reached its peak. The flight crew had nearly lost complete control of the aircraft.
Despite this, the captain continued to fight with all his strength, trying to maintain the nose of the aircraft in a near-level position and even pitched slightly upward, allowing the plane to briefly climb to about 1,500 feet. However, the aircraft was rapidly accelerating, reaching a speed of approximately 615 kilometers per hour. At that point, the left side display issued a stall warning. Although the pitch angle was only about 2.5 degrees, the aircraft began to wobble slightly side to side, its flight condition extremely unstable, as if it could break apart at any moment.
Facing the imminent risk of complete loss of control, the pilots of Ethiopian Airlines Flight 302 launched one final coordinated attempt to regain control. Both pilots simultaneously pressed and held the electric trim button for approximately 9 seconds, successfully adjusting the horizontal stabilizer trim back to 2.3 units, which temporarily interrupted the control of the Maneuvering Characteristics Augmentation System, MCAS. Next, the first officer suggested turning off the trim system, and the captain immediately cut power to the trim motor, fully disabling the stabilizer trim mechanism. However, the problem was not resolved. The horizontal stabilizer remained in an unfavorable position, and the captain had to rely entirely on over 40 kilograms of physical force to pull back on the control column and prevent the aircraft from diving.
At 8:40, the captain requested the first officer's help in pulling back on the control column to raise the nose of the aircraft. The first officer immediately complied. At the same time, the captain instructed the first officer to inform air traffic control that they were experiencing a serious flight control system failure and were requesting to maintain an altitude of 14,000 feet in order to manage the issue.
Air traffic control immediately approved the request and asked about the crew's intended next steps. However, the first officer only replied that they would respond later. Meanwhile, the aircraft's flight path became increasingly erratic and difficult to control. When the pilots pulled back on the control column with coordinated effort, the nose of the aircraft briefly pitched up to nearly 7 degrees, with a climb rate of 4,400 feet per minute. But the moment the first officer released pressure slightly to operate other instruments, the aircraft immediately pitched down again, with a descent rate of up to 2,500 feet per minute.
Although the autopilot panel had been set to a target altitude of 14,000 feet, the aircraft's speed continued to increase, exceeding safe operational limits. An overspeed warning alarm began sounding in the cockpit, and the situation grew increasingly critical. There was a tone of desperation in the captain's voice as he urgently asked, "Is the trim system still working?" First officer responded, "No, it's not working. I'll try manual." But at that very moment, they encountered yet another catastrophic problem. The manual trim wheel was completely jammed. The first officer attempted to fold out the trim crank handle and applied all his strength to turn it. But the system was entirely frozen, completely unresponsive, rendering any attempt to regain control nearly impossible. In a state of utter despair, the first officer shouted, "It's no good, it won't move." The cockpit filled with a cacophony of noises, the roar of the engines, system alarms, the pilot's heavy breathing, and cries of frustration. They were fighting with everything they had to regain control of a plane that was now beyond their command. The captain finally instructed the first officer to request permission from ATC to return to the airport. ATC immediately confirmed their request and instructed them to turn to a heading of 260 degrees. But even so, keeping the aircraft stable remained an incredibly difficult task. The captain kept urging the first officer, "Keep pulling up the nose. If you let go, it'll dive." The pilots had to exert constant force on the control column, unable to relax for even a second. Every second was a tug of war with death.
Shortly afterward, the flight crew attempted to restart the fault diagnosis procedure, something they had not been able to complete since takeoff. The inspection results indicated that the problem was related to the stall protection system and the left angle of attack sensor. At this moment,
the crew finally confirmed that the direct cause of the flight control confusion was the erroneous data transmitted from the left side sensor.
8:43. The first officer switched the electric trim system back on. The captain attempted once again to engage the autopilot system, but was unsuccessful. Just 5 seconds later, the Maneuvering Characteristics Augmentation System, MCAS, was activated one final time, automatically trimming the horizontal stabilizer down to 1 unit, causing the aircraft to enter a steep dive. At this point, the aircraft was completely out of control. The descent rate reached 5,000 feet per minute, and the airspeed exceeded 700 kilometers per hour. Despite both pilots pulling back on the control columns with all their strength, they were unable to stop the aircraft from plummeting. Moments later, the ground proximity warning system issued its final alert.
Terrain, terrain, pull up, pull up. Terrain, terrain, pull up, pull up. Terrain, terrain, pull up, pull up.
At 8:43, the aircraft crashed vertically into a farmland near Addis Ababa Airport. The impact was immense, leaving a crater over 10 meters deep. All 157 people on board perished instantly. There were no survivors. Following the loss of radar signal and radio contact, emergency response protocols were immediately activated. Search and rescue teams quickly located the crash site. This was the second fatal crash involving the Boeing 737 MAX, and news of it spread rapidly across the globe. It sent shockwaves through the entire aviation industry and triggered the most significant investigation in modern aviation history. After the accident, firefighting units and police from a nearby Air Force base rushed to the scene to extinguish the blaze.
The crash site was immediately sealed off to allow investigators to collect evidence. The Ethiopian Red Cross and the Aviation Accident Investigation Team quickly intervened. The Ethiopian Civil Aviation Authority, which is responsible for civil aviation accident investigations in the country, soon launched a full-scale investigation. On April 4, 2019, the Ethiopian Civil Aviation Authority released its preliminary report. Although the report did not explicitly name the MCAS system, it indicated that shortly after the nose was pulled up, the system automatically issued a command to push the nose down again. The flight crew attempted to terminate MCAS intervention by cutting off its power supply, but the system continued to exert erroneous control inputs. The report confirmed that, quote, throughout the flight, the engines remained at takeoff thrust and the auto-throttle system did not adjust power. At one point, within just 30 seconds, the horizontal stabilizer was pushed down to minus 4.2 degrees by the system, and only after the pilots manually intervened and cut the power was it briefly corrected. On December 23, 2022, the Ethiopian Civil Aviation Authority released its final investigation report. The report clearly stated that the fundamental cause of the crash was erroneous data from the angle of attack sensor, which led the Maneuvering Characteristics Augmentation System, or MCAS, to be erroneously activated, continuously pushing the aircraft's nose downward. In the final seconds, the aircraft plunged vertically into the ground at a rate of 33,000 feet per minute. This disaster became one of the most severe accidents involving the Boeing 737 MAX model, triggering widespread condemnation and scrutiny around the world. Boeing came under unprecedented pressure, with dozens of countries around the globe grounding the 737 MAX fleet. The US FAA and Boeing were pushed into the spotlight, and the aviation manufacturing industry began a systemic reform focused on design safety and transparency. This tragedy became one of the most cautionary events in the history of aviation.